Hello there, and welcome to the Sleepless Scientist. Tonight, we drift outward, beyond our sky, beyond even the reach of our sun, into the infinite expanse of the universe itself. Together, we'll travel through moments that began before time had meaning, through galaxies that shimmer like islands of fire in an endless sea, and through mysteries that still whisper to us across billions of years. This isn't a journey of urgency or discovery, but of quiet awe, a chance to feel small in the gentlest way possible, to sense our place among the stars, and to rest within the beauty of the unknown. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. The universe begins with the Big Bang. Let's go back, farther back than imagination usually dares to wander, to the very beginning. Around 13.8 billion years ago, everything we know and everything that ever will be was compressed into a single, unimaginably small point. Then in an instant, it expanded. Space itself stretched outward, carrying with it the raw ingredients of matter, energy, and time. The Big Bang wasn't an explosion in space. It was the creation of space. In its first flicker, the universe blazed with light and heat. A storm of particles colliding, combining, and forming the first whispers of atoms. From that searing beginning, the cosmos began its slow, graceful unfolding. And even now, the echo of that birth still lingers, humming softly through every corner of existence. The first moments after creation. In the first second of existence, the universe was a storm of transformation. Temperatures soared into the trillions of degrees, matter and energy exchanging forms in a dance of creation. Tiny particles, quarks and leptons, collided to build protons and neutrons. Time itself had just begun, and yet in those first breaths, the laws of physics were already settling into place, shaping the destiny of stars, galaxies, and life itself. As expansion continued, the universe cooled just enough for hydrogen and helium to take form. The simplest atoms, the first building blocks of everything to come. These fleeting early moments are gone. But they are not lost. Every atom in our bodies carries their legacy. Cosmic background radiation still glows. Think about this. All around us, faint and invisible, the light from the Big Bang still glows. This ancient radiation, stretched by billions of years of expansion, now hums softly as microwaves, a cosmic afterglow that fills every patch of the sky. The cosmic background radiation is the oldest light we can see. A map of the infant universe frozen in time. It's not bright. It's a whisper of warmth, just a few degrees above absolute zero. Yet from it, scientists have learned the age, shape, and history of the cosmos itself. When you close your eyes at night, remember, there is ancient light still washing over you. A quiet memory of creation that never truly faded. The universe expands every second. It might seem that the stars above are fixed, eternal. But in truth, the universe is still stretching, its galaxies drifting farther apart with every passing second. This expansion is not motion through space. It is space itself growing, carrying everything within it, like dots on an inflating balloon. Distant galaxies move away faster the farther they are, and at great enough distances, their light becomes too red, too faint for us to see. This ceaseless expansion means the universe is dynamic and alive, always changing, always unfolding. Someday, galaxies now visible will slip forever beyond our sight, carried away by the very fabric of space-time itself, galaxies drifting apart forever. Here's something both beautiful and melancholy. As the universe expands, galaxies beyond our local cluster are moving away faster than light can ever catch up. In the far future, their glow will fade into the darkness, leaving only a few neighboring galaxies visible in the night sky. The cosmos will grow quieter, colder, lonelier. Yet even in this slow drift towards solitude, there's serenity. It is the natural rhythm of time on the grandest scale, the quiet dispersal of energy into stillness. Galaxies drifting apart forever is not an ending, but a continuation of what began in that first brilliant burst, the universe expanding, always, into infinite possibility. The observable universe has limits. At first glance, it might seem the universe stretches endlessly in all directions, and it does, but our view of it does not. The observable universe is like a glowing sphere around us, nearly 93 billion light-years across, limited by the age of light itself. Beyond that horizon, there are realms we can never see, not because they don't exist, but because their light hasn't had time to reach us yet. When we look at the night sky, we are not seeing distance, we are seeing history. Every glimmer, every faint galaxy shows us how it once was, not how it is now. The further we look, the further back in time we peer, until we meet the dawn of creation itself. Beyond that point lies the truly unseen, an infinity of galaxies, silent and unreachable, drifting forever beyond our cosmic horizon. The vast scale, beyond imagination. Try to imagine scale, not numbers but feeling. Between galaxies, there are oceans of nothingness. Distances so great that light itself takes millions or billions of years to cross them. The Milky Way, vast beyond measure, is but a single swirl among hundreds of billions. Even our own sun, massive in human terms, is just one star among countless others. And yet, despite the unimaginable immensity, the universe is connected. Every atom that forms stars, planets, and people was once part of the same primordial dust. The vastness isn't empty, it's full of possibility. A quiet testament to the richness of existence itself. In contemplating this, something stirs within us: awe, humility, and a strange sense of belonging. Our Milky Way's place in the cosmos. The Milky Way is our home, a great spiral galaxy, 100,000 light-years wide, filled with dust, gas, and over 200 billion stars. From Earth, we see it as a soft band of light crossing the sky, a reminder that we dwell within its glowing arms. Our solar system orbits about halfway from the center, moving at nearly 500,000 miles per hour, yet taking 225 million years to complete a single circuit. At the heart of the Milky Way lies a supermassive black hole, around which everything turns, unseen but powerful. And all around, like quiet neighbors, are other galaxies, other spirals and clusters, each with their own stories, their own forms of light. Spiral galaxies and their beauty. Think of a spiral galaxy, delicate arms unfurling through the dark, filled with the blue glow of young stars and the faint shimmer of cosmic dust. These graceful forms are among the universe's most beautiful structures, shaped by rotation and gravity, symmetry and chaos. The arms are not solid. They are waves of star formation, places where gas and dust gather to give birth to new suns. In photographs, spirals look frozen in time, but they are alive, ever-changing, the result of millions of years of cosmic movement. Our own Milky Way is one such spiral, a celestial pinwheel of light slowly turning in the quiet dark. Elliptical galaxies filling the sky. Now imagine something different. Elliptical galaxies are vast, featureless ovals, ancient collections of stars long past their prime. They are the graveyards of the cosmos, where star formation has nearly ceased, leaving behind old red suns glowing faintly. Some are small and gentle, others are titans, holding trillions of stars in smooth, luminous halos. They form when galaxies collide and merge, their structure settling into a calm, rounded mass over eons. Though less visually striking than spirals, ellipticals are beautiful in another way. Quiet, massive, enduring. They remind us that even in the universe, there is a time for creation and a time for rest, and that stillness too is part of the cosmic rhythm. Irregular galaxies and their chaos. Here's something wild. Not all galaxies follow neat patterns. Irregular galaxies are the free spirits of the cosmos, shapeless, asymmetric, and filled with bursts of star formation. They are often the result of collisions or gravitational distortions, their delicate balance disturbed by encounters with larger galaxies. Clouds of gas and young stars spill out in unpredictable forms, glowing in hues of blue and pink. To look upon them is to see cosmic creativity at its most chaotic, a universe experimenting without rules. And yet, within this disorder there is life and light, proof that beauty often grows from turbulence. Irregular galaxies may lack symmetry, but they tell a story of resilience, the universe forever remaking itself from its own chaos. Star nurseries and galactic clouds. Let's drift into the soft, glowing depths of a nebula. a vast cloud of gas and dust, shimmering with starlight. These are the birthplaces of stars, where gravity gathers hydrogen and helium into dense knots that ignite into light. Within these cosmic nurseries, entire generations of suns are born, surrounded by swirling disks of dust that may one day form planets. The Orion Nebula, the Eagle Nebula, the Carina Nebula, each is a cradle of creation, vast beyond imagining and breathtaking in their beauty. When we gaze upon their pastel clouds in telescope images, we're witnessing time, slowed almost to stillness. These are places where light is sculpted, where the universe paints with hydrogen and gravity, creating suns that will shine for billions of years. Supermassive black holes at galactic hearts. At the center of nearly every galaxy, including our own, lies a presence of unimaginable density. A supermassive black hole, millions, sometimes billions, of times more massive than the Sun. These objects anchor their galaxies, shaping orbits and growth, yet they are paradoxes, invisible, yet luminous in their influence. Around them, matter spirals inward at near light speed, heating into brilliance before vanishing beyond the event horizon. Our own galactic heart, Sagittarius A, slumbers quietly compared to others, but even it commands the dance of countless stars. To think that such immense darkness can define so much light is to realize the universe's quiet balance. Creation and destruction intertwined, motion and silence coexisting at the heart of everything. Stars live and die in cosmic cycles. Every star, no matter how brilliant, is part of a great cosmic rhythm of birth, life, and death. Small stars burn steadily, lasting for tens of billions of years. Giants blaze fiercely, consuming their fuel in mere millions. In death, stars return their material to space, seeding new generations with heavier elements forged in their cores. Iron, gold, oxygen. The atoms that form our bodies were born in ancient suns. The night sky is not simply a scattering of distant fires, but a living ecosystem of energy, transforming endlessly. To look at the stars is to look at the story of recycling on a cosmic scale. Creation reborn from the ashes of what came before. Red dwarfs are the most common stars. Here's something that feels quietly reassuring. Most stars in the universe are small and steady. Red dwarfs, cool and dim compared to our sun, make up about 3/4 of all stars. They burn their fuel slowly, glowing softly for trillions of years, far longer than the universe has even existed. Though faint to the eye, they outnumber bright stars by the billions. Hidden in every patch of the night sky, many may host planets, some even in their gentle habitable zones. When the grander suns have all faded, red dwarfs will remain, softly illuminating the cosmos like embers in a vast eternal dark. Their persistence is a reminder that even the quietest lights can outlast the brightest flames. Giants and supergiants that burn bright. Now imagine their opposites, massive stars that live fast and die spectacularly. Giants and supergiants burn with fierce intensity, radiating more light in a few million years than smaller stars do over billions. Betelgeuse, Rigel, and Antares are among these titans, their outer layers swelling to colossal size. Their lives are brief but magnificent, ending in powerful supernovae that scatter elements into the galaxy. Without them, there would be no iron in our blood, no calcium in our bones, no gold in our jewelry. These stars remind us that even brief lives can leave lasting legacies, and that brilliance, though fleeting, has the power to shape worlds long after its light has faded. White dwarfs as quiet stellar remnants. When a star like our sun exhausts its fuel, it doesn't end in chaos, but in quiet transformation. Its outer layers drift away, forming a fragile, glowing shell of gas, a planetary nebula, while the core collapses into a white dwarf. What remains is a remnant no larger than Earth, yet with nearly the mass of the sun, an ember of unimaginable density. Its light is no longer powered by fusion, but by residual heat slowly radiating into the void. These white dwarfs shine with calm persistence for billions of years before cooling into darkness. Each one is a relic of an age gone by, a whisper of energy left behind after a star's long life. Astronomers sometimes call them stellar ghosts, And perhaps that's what they are. Luminescent memories marking where a sun once burned, quiet, enduring, and patient. They remind us that even after great brightness fades, something beautiful can remain. Neutron stars, dense beyond belief. Some stars end their lives less gently. When a massive star collapses in on itself, the force is so immense that protons and electrons merge to form neutrons. The result is a neutron star, an object so compact that a teaspoon of its matter would outweigh mountains. These stars, barely 20 kilometers wide, contain more mass than our sun. They are among the most extreme things in existence, bending light and warping space around them. A newly formed neutron star spins rapidly, glowing in X-rays and radio waves, a cosmic ember pulsing through eternity. Their surfaces are harder than diamond, their gravity unthinkable, yet they exist in perfect delicate balance. The universe's reminder that nature's extremes can coexist with exquisite order. In the silence of deep space, these invisible jewels shimmer faintly, proof that the laws of physics, when pushed to their limits, create wonders that border on the impossible. Pulsars spinning with perfect rhythm. And then there are pulsars, neutron stars that spin with astonishing precision. As they rotate, they emit twin beams of radiation from their magnetic poles. When one of those beams sweeps past Earth, we detect a flash of light or radio waves, repeating perfectly with each rotation. Some spin hundreds of times per second, their rhythm unwavering over decades. When they were first discovered in 1967, their regular pulses were so uncanny that scientists briefly nicknamed them LGM for little green men. But pulsars, we now know, are purely natural, though no less extraordinary. They are clocks forged by collapse. Their timing so precise that astronomers use them to measure cosmic distances and even detect gravitational waves. In a universe filled with turbulence and chaos, pulsars offer something rare, a sense of order, of repetition, of music. Each pulse is a heartbeat of the cosmos, steady and eternal. Supernovae as the universe's fireworks. There are few spectacles in nature more powerful or more transformative than a supernova. When a massive star reaches the end of its life, it collapses inward, then rebounds outward in a brilliant explosion. For a few weeks, it can outshine an entire galaxy. But this is not just destruction. It's creation in disguise. In those final moments, the star forges heavy elements, iron, gold, silver, oxygen, and casts them into space. Every atom in your body, heavier than hydrogen, was born in such a fire. The calcium in your bones, the iron in your blood, the gold on a ring, all once formed in the death throes of a distant sun. The remnants of supernovae drift through the galaxy, mixing with gas and dust to form new stars and planets. So when you look up at the night sky, remember, you are made of stars, not simply by poetry, but by physics, by the ceaseless renewal of matter and light. Gamma ray bursts across the cosmos. And then there are moments of almost incomprehensible brilliance. Gamma ray bursts, the brightest flashes known in the universe. Some erupt when massive stars collapse into black holes. Others when neutron stars merge, their collision releasing torrents of energy across billions of light years. In just seconds, a gamma ray burst can unleash more energy than the sun will radiate in its entire lifetime. These events are brief but fierce, like the exhalations of creation itself. If one occurred too close to Earth, its radiation could strip our atmosphere. But the cosmos is vast, and we watch them safely from afar. Astronomers see their light as a record of ancient catastrophes, still racing through the darkness after billions of years. In their fleeting brilliance, they show us how dynamic and alive the universe truly is. Violent, yes, but also astonishingly precise in its chaos. The universe, even in its fiercest moments, creates beauty. Cosmic dust clouds and their glow. After all the explosions, after the light fades and the fragments scatter, there is dust. Not the kind that gathers on bookshelves, but ancient cosmic dust, drifting through the darkness between stars. It is made of carbon, silicates, ice, and metals, the raw ingredients of everything solid in the universe. When starlight filters through these clouds, the dust absorbs it, glows faintly, and re-emits it as soft infrared light. To telescopes tuned to those wavelengths, the sky blooms with color. like embers glowing in the ashes of creation. Within these clouds, new stars are born, using the same dust left behind by older generations. In this way, the universe recycles itself endlessly, death feeding birth, destruction giving way to renewal. Every planet, every stone, every living cell began as dust like this. To look into a dusty nebula is to look backward and forward at once, seeing both the ghosts and the seeds of worlds. Dark matter holding galaxies together. Now, imagine peeling away everything you can see, all the stars, planets, and glowing gas, and realizing that what remains unseen outweighs it all. Dark matter makes up about 85% of the universe's matter, yet it emits no light, no radiation, nothing we can directly observe. We know it's there because of gravity. Galaxies spin too fast for their visible mass alone to hold them together. Without dark matter's hidden pull, they would fly apart. Invisible halos of this substance cradle every galaxy, shaping the large-scale structure of the cosmos. Some scientists suspect it's made of particles that barely interact with normal matter. Others think it's a sign of deeper physics, still waiting to be uncovered. Whatever it is, dark matter acts as the silent architect of the universe, forming the scaffolding upon which everything visible hangs. In its mystery, it offers a reminder. Even the unseen can shape everything we know. Dark energy driving the expansion. If dark matter pulls the universe together, dark energy pushes it apart. It is the great opposite force, an invisible pressure embedded in the very fabric of space-time. In the late 20th century, astronomers discovered that not only is the universe expanding, but the rate of expansion is accelerating. Galaxies are drifting away from one another faster and faster, driven by this enigmatic energy. No one knows what dark energy truly is. Some imagine it as a property of space itself. Others see it as a sign that our understanding of gravity is incomplete. Whatever its origin, it now dominates the cosmos, accounting for nearly 70% of everything that exists. Over unimaginable timescales, it may stretch the universe into a quiet, cold emptiness. Yet for now, it is the breath of the cosmos, the soft outward sigh that ensures everything continues to move, evolve, and drift into the unknown. The cosmic web linking all galaxies. Zoom out far beyond our own galaxy, far beyond clusters and superclusters, and you begin to see a pattern. The universe, on its largest scales, is woven together like a vast, glowing net. Galaxies cluster along filaments of dark matter, interconnected across hundreds of millions of light years. Between these luminous threads lie enormous voids, cosmic deserts, where almost nothing exists. Together, they form the cosmic web, a structure so immense and intricate that it mirrors biological systems and neural networks. Through computer simulations and deep sky surveys, we can trace its shape, the filaments of light and gravity stretching endlessly through space. Every galaxy, including our Milky Way, is a bead upon this unseen thread. It's strange to think that the same forces shaping the structure of our universe echo patterns we find in the smallest forms of life. From neurons to galaxies, everything seems bound by an invisible geometry of connection. Vast voids, where nothing exists. Between the filaments of the cosmic web lie spaces so large and empty they defy imagination. These are the cosmic voids, regions spanning hundreds of millions of light years, with almost no galaxies at all. They are the quiet spaces between the notes of the universe's song. To float within one would be to see no nearby stars, no galaxies, only a faint distant glow in every direction. Yet even here, in this nothingness, traces of matter remain. The faintest gas, the thinnest whispers of dark energy, the delicate curvature of space itself. Voids are not lifeless, so much as they are resting places, vast silences that allow the universe's structure to breathe. Their emptiness defines where everything else exists, like the pauses in a heartbeat or the calm between waves. They are part of the rhythm that makes the cosmos whole. In their stillness, the universe finds its balance. Galaxy clusters shaping the universe. When galaxies gather, they do not do so gently. They form clusters, enormous families bound together by gravity, each cluster containing hundreds or even thousands of galaxies swirling through the same shared space. The Milky Way belongs to a small group compared to these giants. Some clusters are so massive that they warp space-time itself, bending light from galaxies behind them in graceful arcs. Within their boundaries, gas glows faintly in X-rays, heated by collisions between galaxies that dance and merge across eons. Astronomers see these clusters as the great cities of the universe, cosmic metropolises connected by filaments of dark matter, their interactions shaping the very architecture of the cosmos. When two clusters merge, the energy released is staggering, enough to send shockwaves through the intergalactic medium. And yet, even within such power, there is beauty, light, structure, and the slow ballet of gravity sculpting order from endless motion. The local group of galaxies we belong to. Our own home lies in a much quieter neighborhood, a modest cluster known as the local group. It's a small family of more than 60 galaxies, gathered within a region about 10 million light-years wide. The Milky Way, Andromeda, and the Triangulum Galaxy are its three largest members, surrounded by a scattering of smaller dwarf galaxies that orbit like companions. Invisible threads of dark matter hold them all in gentle orbit around a shared center of gravity. When we look up at the faint smudge of Andromeda on a clear night, we are gazing at one of our cosmic neighbors, another island of stars drifting alongside our own, though separated by vast distances. These galaxies move together through the greater flow of the universe. The local group reminds us that even on a galactic scale, families form. The cosmos is vast, but it is not entirely lonely. Andromeda approaches the Milky Way. Despite the great emptiness between galaxies, motion never ceases. Andromeda, our nearest large neighbor, is slowly moving toward us at more than 100 kilometers per second. In about 4 billion years, it will collide with the Milky Way. But don't imagine destruction. The space between stars is so immense that most will simply pass by each other unharmed. Over time, gravity will blend the two galaxies into one, an elegant spiral transformed into a new elliptical form that astronomers have already named Milkomeda. When that happens, the night sky from any surviving planet will be extraordinary. Andromeda will grow larger each million years, filling the heavens with ribbons of light until the two merge in a radiant embrace. It's strange to think that our galaxy, which feels so eternal, is itself part of an endless cycle of motion, collision, and renewal. Even galaxies fall in love. Future galactic collision ahead. When the Milky Way and Andromeda finally meet, the process will unfold over hundreds of millions of years, a slow, grand waltz of gravity. First, their outer halos will touch, sending streams of stars arcing through space. Then, their cores will spiral inward, pulled together by their mutual attraction. During this long merging, new bursts of star formation will light up the skies as clouds of gas compress and ignite. Some solar systems may be cast adrift into the intergalactic void. Others will find new orbits in the reshaped galaxy. Eventually, the two will settle into a single massive elliptical galaxy, glowing with the combined light of 1 trillion suns. Far in the future, when the universe grows colder and quieter, this merged galaxy will drift gently through the cosmic web, a serene monument to change. Even on the grandest scales, endings and beginnings are one and the same. The scale of intergalactic distances. It's difficult, perhaps impossible, to truly grasp the distances between galaxies. Even the nearest are millions of light years away. A beam of light, traveling at 300,000 kilometers per second, would take over 2 million years just to bridge the space between us and Andromeda. Beyond that lie hundreds of billions more galaxies, each separated by unfathomable gulfs of emptiness. When astronomers say nearby, they mean what, to us, would seem endlessly far. The cosmic web stretches these distances even further, connecting clusters and voids across hundreds of millions of light years. And yet, despite these immense separations, the universe remains connected through gravity and light, through the faint pull of unseen matter and the lingering glow of ancient photons. It is humbling to realize that everything we know, the sun, the planets, even the Milky Way, is just one spark in an ocean too vast to ever fully comprehend. The speed of light is a cosmic limit. Light is the universe's great messenger. It crosses the void between stars and galaxies, carrying with it the story of everything it touches. Yet it also imposes the ultimate speed limit. Nothing can travel faster. At 300,000 kilometers per second, light moves with unfathomable swiftness. But across the cosmos, even that is slow. When we gaze at a distant galaxy, we see it not as it is, but as it was. perhaps millions or even billions of years ago. The light that enters your eyes tonight began its journey before humans existed, before Earth had taken its modern shape. It means that, in a sense, every night sky is a time machine, showing us echoes of the past rather than the present. The universe reveals itself to us in slow motion, and that slowness gives it meaning. The cosmic speed limit ensures that time, distance, and memory are forever intertwined, so that nothing, not even light, escapes the rhythm of eternity. Time dilation across the universe. Einstein taught us that time is not universal. It stretches and bends depending on speed and gravity. Move fast enough, and time slows down. Fall close enough to a massive object, and moments stretch into infinity. In the deep cosmos, this isn't philosophy, it's daily reality. Around black holes, time can crawl so slowly that seconds for one observer might equal centuries for another. Even light itself feels this warping, curving around massive stars as if space were a soft, flexible fabric. Imagine two twins, one staying on Earth, the other traveling near the speed of light. When they reunite, the traveler will have aged less, a living echo of the universe's relativity. Time dilation is not a trick, but a truth. The cosmos does not treat time as fixed, but as fluid, alive, and deeply connected to motion. It reminds us that in a universe where everything moves, time itself becomes a dance partner. Gravitational waves, rippling through space. In 2015, the silence of the universe was broken, not by sound, but by the trembling of space itself. Scientists detected gravitational waves, ripples in the fabric of space-time caused by the collision of two black holes more than 1 billion light-years away. They passed through Earth like faint tremors, stretching and compressing everything, though by less than the width of an atom. Yet that tiny vibration carried the story of cataclysmic power. Einstein had predicted them a century earlier, but only now could we listen. These waves are the heartbeat of the cosmos, the universe's way of whispering its most dramatic moments. Black holes merging, neutron stars colliding, galaxies dancing in gravity's grip. To detect them is to eavesdrop on creation itself. Somewhere, even now, countless ripples travel outward from ancient events, their gentle quiver connecting the present to the past, reminding us that even silence can speak volumes. Black holes bending. Time and space. If you could approach a black hole, time itself would begin to slow. The gravitational pull near its edge, its event horizon, is so immense that not even light can escape. To an outside observer, anything falling in appears to freeze, stretched endlessly toward the brink. To the falling traveler, though, time would seem perfectly normal until it ends. Black holes are paradoxes given form, where the laws of physics as we know them break down. They warp space and time so dramatically that they act like mirrors of gravity itself, dense, invisible, and profoundly mysterious. Some spin rapidly, surrounded by disks of matter, heated to millions of degrees. Others drift silently, swallowing stars whole. Yet they are not purely destructive. Many scientists believe black holes help regulate galaxies, influencing star formation and cosmic balance. They are both monsters and midwives of creation. Proof that even in darkness, the universe's design has purpose. Event horizons, where time stops. The event horizon of a black hole is a boundary unlike any other. It is the ultimate edge, a point of no return. Once crossed, all paths lead inward, toward the singularity where space and time collapse. To an outside observer, nothing truly crosses it. Instead, light slows, reddens, and fades, stretched to infinity. For the falling object, however, it's different. They experience no sharp boundary, no sudden change, only an ever-steepening descent. It's as if reality itself is divided between perspectives, two truths existing side by side. The event horizon is a reminder that limits in physics are often mirrors for limits in understanding. We cannot see beyond it, cannot measure what lies within, and so it stands as the universe's final curtain. Behind it, matter, light, and time are rewritten into forms we can't yet imagine. The event horizon is not merely a place, it's a mystery made visible, the edge of knowing itself. Wormholes, theoretical bridges of space. Let's imagine, for a moment, that space is not a vast, empty expanse, but a pliable fabric, foldable, twistable, connectable. Wormholes, in theory, are shortcuts through this fabric. tunnels linking distant parts of the universe, first predicted by Einstein and Nathan Rosen in 1935. These Einstein-Rosen bridges could, in principle, allow travel between stars or even between universes. But like many beautiful ideas, they remain elusive. To keep a wormhole open, one would need exotic matter, something with negative energy, capable of resisting collapse. No such material has ever been found. Still, the notion lingers, poetic and hopeful. If the cosmos does allow shortcuts, perhaps somewhere, light is looping through hidden corridors, connecting distant galaxies in ways we cannot yet perceive. Wormholes are the imagination's way of whispering. What if distance isn't as absolute as it seems? The multiverse hypothesis of many realms. What if our universe is just one bubble in an endless cosmic sea? The multiverse theory suggests that countless universes may exist, each with its own laws of physics, its own dimensions, its own histories. Some might contain galaxies and stars like ours. Others could be ruled by entirely different forms of matter, energy, or time. It is a dizzying thought, one that stretches the human mind beyond comfort. Yet the mathematics of cosmology and quantum mechanics both hint that our reality might not be the only one. Perhaps every decision, every quantum event, spawns a new branch of existence, each running parallel to our own. If that's true, then infinite versions of you and me could exist, some living under alien skies, others never born at all. The multiverse offers no comfort or certainty, but it does offer wonder, a reminder that even infinity might be bigger than we think. Parallel universes, in infinite possibilities. Think about this. Somewhere, in another universe, there might be a world almost identical to ours. Same Earth, same stars, same night sky, but where one tiny detail is different. Perhaps a single leaf fell to the left instead of the right. Or perhaps entire histories unfolded along different paths. The idea of parallel universes flows from quantum theory, where every possible outcome of an event may actually occur, each in its own separate reality. These worlds would never interact, yet they would all be as real as ours. Some scientists find comfort in this elegance. Others feel its chill, the quiet suggestion that our choices may echo infinitely. Yet whether literal or metaphorical, the notion of parallel universes invites a softer reflection, that every moment is a crossroad, and each breath carries the weight of endless possibilities. The universe, it seems, is never content with only one version of beauty, inflation expanding the early universe. Let's travel back to the universe's first heartbeat, an instant so brief that it could fit within a trillionth of a second. During that moment, known as cosmic inflation, the universe expanded faster than light, stretching quantum fluctuations into the seeds of galaxies and stars. Space itself swelled outward, smooth and uniform, yet speckled with subtle irregularities that would one day form everything we know. Inflation explains why the cosmos appears so balanced, and why its microwave background glows so evenly across the sky. But this theory also carries a secret. If inflation happened once, it might never truly have stopped. Some cosmologists believe new universes are still budding off from the old, eternally multiplying in a cosmic cascade. Our universe, then, could be one bloom in an infinite garden, each expanding silently into its own eternity. The cosmic microwave background secrets. Everywhere you look in the sky, between stars, beyond galaxies, through the darkest regions, there is a faint, ancient glow. This is the cosmic microwave background, the afterglow of the Big Bang itself, born 380,000 years after the universe began. It is the oldest light we can see, stretched by expansion until it now hums in microwave wavelengths. To the naked eye, it is invisible, but to radio telescopes, it paints a delicate pattern of warmth and coolness, tiny ripples that tell the story of the cosmos's first moments. Within those ripples are clues to everything: how matter formed, how fast the universe expands, even hints of what came before. Every photon of that background has been traveling for over 13 billion years, carrying the memory of creation. To gaze upon it, even through data and images, is to look at the universe's first light, soft, eternal, and unimaginably far away. Ancient light from the first stars, long before galaxies took shape. before planets formed, before even the idea of life could exist. There were the first stars. They were immense, hundreds of times more massive than our sun, burning with blinding brilliance in a universe still wrapped in darkness. Their light, the first to pierce the cosmic night, transformed everything. These primordial stars forged the first heavy elements in their hearts, scattering them when they died in spectacular explosions. In their ashes lay the building blocks of worlds, oceans, and life. The light from those early suns still travels through space, stretched into faint red whispers by billions of years of expansion. When astronomers capture it with their telescopes, they are not just studying distant radiation, they are listening to the echoes of creation's first dawn. In that faint ancient glow, we find both our beginnings and the promise that the universe never truly stops awakening. Quasars as cosmic beacons. At the heart of distant galaxies, monstrous black holes devour matter with insatiable hunger. Yet instead of darkness, these feeding grounds shine brighter than anything else in the cosmos. We call them quasars, quasi-stellar objects, and they blaze with the energy of entire galaxies compressed into a single brilliant point. The light from a quasar can travel for billions of years, reaching us as a message from the deep past, a time when the universe was young and restless. Quasars serve as cosmic lighthouses, helping astronomers map the farthest reaches of space. Some flicker, some flare, and some pulse in perfect rhythm, revealing the turbulence at their core. Their brilliance is paradoxical, born from the grip of gravity so strong that it should consume all light, and yet producing luminosity beyond measure. Quasars remind us that even in the universe's darkest regions, there are forces that burn with unimaginable intensity, blazars pointing straight at us. Every quasar hides a supermassive black hole, but when its jet of energy happens to aim directly at Earth, we see something even more extraordinary. A blazar. These are among the most violent objects known, emitting bursts of gamma rays and X-rays that travel across the cosmos. A blazar's brightness can change in minutes, suggesting that its heart is astonishingly compact, no larger than our solar system. Yet the power it radiates dwarfs that of entire galaxies. To us, they appear as flickering, unpredictable beacons, the universe's own lighthouses, flashing through eternity. The name may sound fierce, but in truth, there's a strange serenity in imagining such power aimed silently our way. Its journey lasting billions of years. Every photon that reaches our telescopes has crossed unimaginable distances to whisper, "I was here," once in the heart of a cosmic storm. Magnetars with extreme fields. There are stars that die and become something stranger still, neutron stars, compressed beyond reason. And among them, a few are born with magnetic fields so intense that they defy comprehension. These are magnetars. If you could stand 1,000 kilometers away, their magnetic pull would erase every trace of your existence. A magnetar's field is trillions of times stronger than Earth's, twisting space and bending matter at the atomic level. When they flare, they unleash bursts of energy so powerful they can be detected across the galaxy. Yet they are rare and short-lived, fading into quiet solitude after their brief, furious outbursts. The calm that follows their storms feels almost sacred. In the grand symphony of the universe, magnetars play the loudest, most haunting notes, reminding us that even the cosmos's smallest remnants can hold unimaginable power. Rogue planets, wandering alone. Not every world belongs to a star. Some are born within systems but cast adrift, flung into the cold by gravitational encounters or stellar chaos. These are the rogue planets, lonely travelers drifting through the interstellar dark, with no sunrise, no orbit, no home. Some may still carry heat in their cores, their surfaces shrouded in perpetual twilight. Others might cradle frozen oceans beneath layers of ice, preserving the secrets of their birth. Imagine such a planet, silent and slow, gliding endlessly between the stars. Its nights are eternal, yet it moves through a universe alive with distant light. Astronomers believe there could be billions of these orphans. More than the stars themselves, they are the wanderers of creation, reminders that even in the vast emptiness, there are worlds adrift, each carrying the quiet dignity of solitude through the infinite night. Exoplanets, orbiting other suns. For most of human history, we looked at the stars and wondered if any of them held worlds like our own. That question began to find its answer only recently. In the last few decades, astronomers have discovered thousands of exoplanets, planets orbiting distant suns, scattered across the galaxy like cosmic seeds. Some circle close to their stars, glowing red-hot and fast. Others drift in wide, frozen orbits where sunlight never reaches. We find them through delicate measurements, the tiny dimming of a star's light, the faint tug of its gravity, the subtle shift in its color. Each detection is a revelation, a new world, unseen but real. Some are rocky like Earth, others gaseous like Jupiter, and a few seem too strange to imagine, planets made of diamond or shrouded in iron rain. Each one expands our sense of possibility, whispering that the universe may be far more generous than we ever dreamed. Goldilocks zones and potential life. Among the countless stars and planets, there exists a delicate balance, a narrow ring around each sun, where conditions might be just right for life. Not too hot, not too cold. We call it the Goldilocks zone, and it's here that liquid water could flow, where oceans might shimmer beneath alien skies. Earth sits within such a region, and it's tempting to wonder how many other worlds share that sweet spot. The search for life beyond our planet often begins here, guided by light spectra that hint at water vapor, oxygen, or methane in far-off atmospheres. Yet habitability is more than chemistry. It's patience, time, and chance working in harmony. Somewhere out there, in a soft orbit around an unseen sun, a world may already be stirring with life. It might not resemble ours, but it breathes the same cosmic inheritance, the possibility written into the fabric of the universe itself. Water worlds and ocean planets. Imagine a planet covered entirely in water. No continents, no islands, just endless rolling oceans. Astronomers believe such worlds exist, where deep seas stretch for thousands of kilometers, hiding rocky cores beneath crushing pressure. On some, the water might freeze into exotic ice, harder than steel, yet still floating on deeper liquid layers. These ocean planets could be teeming with potential, their surfaces calm and blue under distant stars, their depths warm with geothermal energy. Even in our own solar system, moons like Europa and Enceladus hint that life might thrive beneath ice-covered oceans. On true water worlds, the boundary between sky and sea blurs into one continuous mirror, reflecting light that has traveled for eons. They remind us that life's most fundamental ingredient, water, is not rare, but abundant, scattered across the galaxy like a quiet promise. The universe, it seems, loves to dream in shades of blue, super-Earths and their potential. Some planets are neither Earth-like nor giant, something in between. Astronomers call them super-Earths, worlds 2 to 10 times our planet's mass. Many of them are rocky, with thick atmospheres and immense gravity. If you could stand on one, you might weigh twice as much, your footsteps heavier, your breath thicker with strange air. Some super-Earths orbit red dwarf stars, basking in gentle perpetual twilight. Others spin close to their suns, locked in scorching days and frozen nights. Their diversity is astounding. A few might harbor oceans deeper than any found on Earth. Others may have entire skies of clouds heavy with mineral rain. To scientists, super-Earths are both familiar and alien. Cousins of our world, but shaped by different histories. They may be the most common type of planet in the galaxy, offering endless variations on the same theme, the universe's enduring fascination with worlds like ours, but not quite. Gas giants as mini solar systems. Far beyond the warm inner zones of stars lie the gas giants, enormous planets wrapped in clouds of hydrogen and helium. Jupiter, Saturn, and their distant kin are not just planets. They are miniature solar systems, each surrounded by a retinue of moons. Some of these moons are icy deserts, others volcanic and alive with movement. A few, like Titan and Europa, could even harbor the ingredients for life. Around other stars, astronomers have found gas giants so close to their suns that they complete orbits in mere days. Hot Jupiters with atmospheres whipped into storms of vaporized metal. Others drift far out, colder than any Arctic night, faint and slow in their orbits. Despite their differences, all gas giants share a kind of majesty, a sense of scale that humbles. They are the anchor worlds of their systems, vast enough to shape the dance of smaller bodies, silent guardians of cosmic order. brown dwarfs between stars and planets. There exists a twilight class of objects, not quite stars, not quite planets, brown dwarfs. They form like stars, collapsing from clouds of gas, but never ignite into full nuclear fusion. Too small to shine, too large to simply drift as planets. They glow faintly, in infrared, radiating the last warmth of their birth. Some are only a few times heavier than Jupiter. Others nearly cross the threshold into stardom. They drift alone through the galaxy, unseen by the naked eye. Their light soft as an ember in the void. Around some, smaller worlds may orbit, lit by a dim, perpetual dusk. Brown dwarfs remind us that the universe does not always fit neatly into our categories. Between every definition, there lies a spectrum, a quiet gradient of existence. They are the wanderers of the in-between, glowing with the melancholy beauty of things that almost were. Planetary rings, made of dust and ice. When you think of rings, Saturn comes to mind, those bright, breathtaking arcs circling its equator. But rings are not Saturn's alone. Jupiter, Uranus, and Neptune wear their own faint halos, ghostly bands of dust and debris. Even tiny asteroids can host temporary rings under the right conditions. These cosmic necklaces form from shattered moons, captured comets, or remnants of creation, locked in graceful orbit. Each particle, whether a grain of sand or a block of ice, moves according to delicate physics, balanced between gravity and motion. From afar, the rings appear serene, but up close, they are a dance of collisions, whispers of chaos held in harmony. If you could hover above Saturn's rings, you'd see endless waves of light and shadow, sunlight scattering across ice crystals like a frozen sea. Rings remind us that beauty often arises from destruction, and that even fragments can form perfection. Moons larger than planets themselves. Some moons defy expectation. Ganymede, orbiting Jupiter, is larger than Mercury. Titan, Saturn's misty companion, outmasses Pluto several times over. These worlds orbit their parent planets, but each could be a planet in its own right. Ganymede has a magnetic field, a rare trait for moons, and an icy crust that likely hides an ocean beneath. Titan has rivers and lakes, not of water, but of liquid methane and ethane, reflecting a dim orange sky. Even our own moon, though modest in size, shapes tides, seasons, and life itself. Moons are the quiet poets of the solar system, subtle, reflective, yet powerful. They tug gently on their worlds, pulling oceans, influencing atmospheres, stabilizing spins. In their glow, we see a mirror of companionship, a celestial reminder that even in the vastness of space, nothing truly travels alone. Titan's lakes of liquid methane. Imagine standing on the shore of a lake, the air hazy and golden, the ground beneath you frozen solid. Above, a faint sun hangs dimly through thick clouds. This is Titan, Saturn's largest moon, a world where liquid methane and ethane flow like water, filling rivers, seas, and rain clouds. It's the only place beyond Earth where stable liquids exist on the surface. The chemistry here is alien, yet strangely familiar. Methane rain falls softly, carving valleys and dunes across Titan's surface. Beneath its crust of ice, a vast ocean of water and ammonia may hide, warmed by the moon's internal heat. Titan could hold the secrets of early Earth, a laboratory for understanding how life might arise under different conditions. Its still, mirror-like lakes reflect a universe that dreams in many forms, each version of nature writing its own poem of possibility. Europa's hidden ocean beneath ice. Farther from the sun, another moon guards an even deeper mystery. Europa, one of Jupiter's many companions, is sheathed in ice, but beneath that frozen crust lies a global ocean. More water than all of Earth's seas combined. Cracks streak its surface like veins, hinting at movement below. Geysers have been seen erupting from its poles, spraying vapor into space. Scientists believe the ocean beneath might be warm, kept liquid by tidal forces, and a rocky seafloor that could provide the chemistry needed for life. If life exists there, it would be shielded from radiation, thriving in eternal darkness around hydrothermal vents, much like the creatures in Earth's deep seas. Europa reminds us that life may not need sunlight, only energy, water, and time. It is a world that hums quietly with promise, waiting beneath its icy veil for someone to listen closely enough to hear it breathe. Cosmic rays crossing the galaxy. Invisible yet ever-present, cosmic rays travel across the galaxy like messengers of high-energy chaos. They are atomic fragments, protons, electrons, and nuclei hurled through space at nearly the speed of light, born from supernovae and the violent hearts of galaxies. When they strike Earth's atmosphere, they shatter atoms, creating cascades of secondary particles that silently rain down upon us every second. We live beneath this gentle cosmic drizzle, unaware of its constant touch. Cosmic rays are both dangerous and beautiful. Too much of their energy can harm living cells, yet they also carry clues to the most powerful events in the universe. Some have traveled for millions of years, crossing magnetic fields and vast distances, before colliding with a single molecule in our sky. Each impact is a signature of creation's violence, a fleeting reminder that even in stillness, we are always part of the cosmos's restless motion. The Oort cloud at the edge of our sun. Far beyond the planets, past the frozen dwarf worlds and the scattered debris of the Kuiper belt, lies a realm of deep silence. The Oort cloud. It is a vast spherical shell of icy bodies, surrounding the solar system like a distant halo. Its members are ancient, leftovers from the sun's birth, untouched for billions of years. Occasionally, one is nudged from its distant orbit by a passing star or a ripple in gravity, and it begins a long, slow fall toward the sun. As it approaches, it becomes a comet, its frozen gases warming, its tail unfurling like a banner across the night sky. The Oort cloud is so far away that no spacecraft has ever come close. It exists more as an idea than an image, a whisper of what may be. But within it lies the boundary between our solar neighborhood and the interstellar deep, the place where the sun's domain fades into the infinite. Comets as messengers of the early solar system. When you see a comet streak across the sky, you're witnessing the past in motion. Comets are relics from the dawn of the solar system, icy, dusty time capsules containing the same material that once formed the planets. Each orbit brings them back into sunlight, where their frozen surfaces vaporize, forming tails that can stretch millions of kilometers. To ancient peoples, they were omens. To modern scientists, they are storytellers. Every comet carries a record of the early solar disk, the chemistry, temperature, and turbulence of its birth. Some may even have delivered water and organic molecules to the young Earth, seeding it with the ingredients for life. Their beauty is fleeting, their visits rare, but their message endures, that everything we are, oceans, clouds, and breath, may have once been part of a distant wandering traveler that fell from the dark to light the skies of our beginning. Asteroids, holding primordial secrets. Between Mars and Jupiter drifts a vast collection of rocks. Asteroids, remnants of a world that never formed. Some are metallic, forged from the cores of ancient protoplanets. Others are carbon-rich, preserving the chemistry of the early solar system. They come in all shapes and sizes, from pebbles to mountains, silent relics orbiting in the dark. Spacecraft like Hayabusa and OSIRIS-REx have touched these ancient surfaces, bringing back grains of dust older than Earth itself. Each particle is a page from the universe's earliest story, unspoiled by atmosphere or time. When asteroids collide, they sometimes send fragments toward our planet, and those meteorites that reach the ground become gifts from the past. Holding one is like holding the memory of creation, matter forged before life, before oceans, before the world took shape. In their cold, unchanging silence, asteroids remind us how much of the universe endures unchanged, waiting to be understood. Meteor showers as celestial rain. On certain nights, if you step outside and look up, the sky seems to come alive. Meteors streak through the darkness, brief flashes of light that vanish almost as soon as they appear. These shooting stars are fragments of comets and asteroids, burning up as they enter Earth's atmosphere. Each one is no larger than a grain of sand, yet it glows with brilliance, its speed turning dust into fire. Meteor showers occur when Earth passes through a trail of debris left by a comet's orbit, creating predictable displays. The Perseids in August, the Geminids in December. Ancient observers saw them as signs from the heavens. Today we understand them as cosmic leftovers, reminders that our planet still moves through the same space it did billions of years ago. Watching a meteor shower is like witnessing the dialogue between Earth and the cosmos, a quiet, recurring conversation made of light, motion, and time. Light pollution, hiding the stars. There was a time when the night sky belonged to everyone. The stars were a vast ocean, unbroken, endless, alive with stories and wonder. Now, much of that sky has faded. City lights spill upward, scattering through the air, drowning the stars in a pale, artificial glow. It's called light pollution, a gentle name for a quiet loss. Most people today have never seen the Milky Way with their own eyes, never stood beneath a sky so dark that the heavens seem to breathe. Yet above the haze, the stars are still there, burning as they always have. In places far from the cities, on mountain peaks, desert plains, remote islands, the old sky remains. There, the darkness feels alive. The stars return in their billions, and time itself seems to slow. To protect the night is to remember our place within it, to preserve not just a view but a connection to the infinite. The great attractor pulling galaxies. In one direction of the sky, far beyond the familiar constellations, lies a hidden gravitational mystery. Astronomers call it the great attractor, a region of space whose immense pull influences the motion of entire galaxies, including our own. We can't see it directly. It sits behind the dense plane of the Milky Way, shrouded by gas and dust, but its presence is undeniable. Galaxies in our region drift subtly toward it, drawn by a mass so vast that even light struggles to reveal it. Some believe it to be a concentration of galaxy clusters. Others think it's part of an even larger structure, the Laniakea supercluster, the vast cosmic continent we inhabit. The great attractor reminds us that gravity extends its hand across unimaginable distances, shaping the flow of the universe like a silent tide. We are, in some small way, always falling, slowly, gently, toward the unseen. The Sloan Great Wall of Galaxies. Stretching across over 1 billion light-years, the Sloan Great Wall is one of the largest known structures in the universe, a cosmic tapestry woven from hundreds of thousands of galaxies. Imagine a wall so vast that light would take 10 million centuries to cross it. Discovered through sky surveys mapping galactic positions, this immense filament is part of the cosmic web, where gravity gathers matter into delicate, interconnected threads. Within its folds lie clusters and superclusters, each one a city of stars. It is hard to comprehend such scale. Our entire Milky Way is but a speck upon its surface, a single drop in an ocean of galaxies. The Sloan Great Wall stands as a monument to structure itself, the universe's tendency to form patterns, to cluster, to connect. Even in chaos, creation seeks order. Even in emptiness, it weaves form and rhythm, like ripples frozen in space-time. The Buddha's void, a cosmic desert. If the Sloan Great Wall represents abundance, the Buddha's void is its opposite, a vast region of almost nothing. It spans over 300 million light-years across and contains only a handful of galaxies, scattered like lonely islands in an endless sea. Astronomers sometimes call it the Great Nothing. Standing on a planet within it, the sky would be eerily empty, with few stars or galaxies visible at all. The voids are the universe's quiet spaces, formed as gravity pulled matter into filaments, leaving behind immense hollows. They are not mistakes, but part of the grand balance, the breathing pattern of the cosmos. Within that emptiness lies a strange peace, a reminder that space is not just filled with light and matter, but also with silence and stillness. The Buddha's void is the pause between the cosmic notes, the quiet inhale between the universe's endless exhalations, cosmic microwave signals of creation. When astronomers tune their instruments to the faint microwaves that fill all of space, they are hearing the afterglow of the Big Bang itself. This signal, uniform yet dappled with subtle variations, is the echo of creation, the residual radiation from when the universe was young and hot. First detected accidentally in 1965 by 2 radio engineers, this background hum exists everywhere, day and night, no matter where we point our antennas. It tells us that the cosmos was once a dense, glowing fireball that expanded and cooled, giving birth to everything we see. In the tiny temperature differences of that ancient light, we can read the first imprints of structure, the fingerprints of galaxies yet unborn. The cosmic microwave signal is the universe's oldest memory, a whisper of its fiery youth that still resonates across time. Listening to it is like pressing your ear to the cradle of existence and hearing the faint heartbeat of eternity. The age of the universe, estimated in billions. Time in the cosmic sense is almost impossible to grasp. The universe, according to our best measurements, is around 13.8 billion years old. 13.8 billion. Numbers that roll off the tongue easily, yet describe an expanse of time so vast that human history becomes a brief spark in comparison. If the entire history of the universe were compressed into a single calendar year, everything from the birth of our planet to the rise of humankind would occur in the final moments of December 31st, just before midnight. For most of that cosmic year, the universe was silent, forming galaxies, igniting stars, and setting the stage for everything that would follow. Scientists arrived at this number by reading the light of ancient stars, tracing the expansion of space, and studying the fading glow of the Big Bang itself. And still, there's something quietly poetic in knowing that this old universe, born in chaos and fire, still moves gently forward, carrying us through its long and patient story. The fate of stars in the far future. Every star you see tonight, from the faintest flicker to the brightest beacon, is temporary. Stars are born from clouds of gas and dust, live for millions or billions of years, and eventually die in one form or another. The massive ones will explode in cataclysmic supernovae, scattering elements across space. Smaller stars, like our Sun, will expand into red giants and then fade into white dwarfs, glowing embers that slowly cool over trillions of years. Eventually, even those embers will go dark, leaving behind only cold remnants, black dwarfs, invisible to any eye. In the far future, galaxies will dim as their stars die out, the night sky growing quieter with each passing eon. But that distant twilight will not be sad. It will be serene. The matter forged in those stars will live on, in planets, in dust, and perhaps other beings yet to come. Even in death, the stars give back to the cosmos. They end not in silence, but in transformation, heat. Death is the universe's end. Imagine a time so distant that the mind cannot hold it. Stars have burned out, galaxies have drifted apart, and the cosmos has stretched so wide that light itself rarely meets another light. This is the universe's possible end, heat death. Not a fiery explosion, but a slow and inevitable quieting. Entropy, the tendency of energy to spread out and even out, will have done its work. Every star, every particle, every spark of motion will have exchanged its energy, until there is nothing left to move, nothing left to shine. The universe will become a vast, cold equilibrium, a cosmic winter where no new stars are born, and time itself loses meaning. And yet, there's a haunting beauty in this vision. It's the natural conclusion of balance, the long exhale after billions of years of creation and collapse. In the deep future, perhaps the universe won't end in tragedy, but in peace, the final calm after eternity's symphony. Big Rip tearing galaxies apart. But not all cosmologists imagine such a quiet ending. Some theories propose a far more dramatic fate. The Big Rip. If dark energy, the mysterious force driving the universe's expansion, continues to accelerate, it could eventually overwhelm all other forces. Galaxies would first drift apart faster than light could travel between them. Then individual stars would be pulled away from their galaxies, planets torn from their orbits, and finally, atoms themselves ripped apart. It's a scenario of cosmic unraveling, where even the fabric of space-time tears itself to pieces. The Big Rip might occur tens of billions of years from now, or never at all. No one knows for certain, but thinking about it reminds us how fragile structure truly is. Everything, from galaxies to the molecules in our hands, exist because forces hold them together. And in a universe ruled by expansion, even that togetherness might one day be undone. The Big Rip is terrifying. Yes, but also strangely poetic. Creation and destruction, forever entwined in cosmic rhythm. Big Crunch is a possible collapse. Then again, perhaps the universe won't fade away or rip apart, but turn inward. The Big Crunch is the opposite of the Big Rip. A grand implosion instead of an explosion. If gravity someday overcomes dark energy, the expansion of the universe could slow, halt, and then reverse. Galaxies would begin to drift closer again, stars drawn back toward one another, until everything collapses into an unimaginable density, a mirror of the Big Bang that started it all. In that final moment, space and time would fold in upon themselves, and all matter would merge into a single point of infinite heat and pressure. And perhaps, from that singularity, a new universe might bloom, a new beginning born from the ashes of the old. The idea of the Big Crunch offers a strange comfort. It speaks of cycles, of renewal. The universe, after all, has always balanced endings with beginnings. What if creation is not a single event, but a heartbeat, forever pulsing, expanding, and contracting through infinity? Eternal inflation and endless universes. Let's imagine for a moment that the Big Bang was not a single unique event. What if it was simply one spark in an eternal blaze, one bubble in an infinite sea of creation? This is the idea of eternal inflation, a theory that suggests our universe is not the only one, but part of an endless chain of expanding bubbles. In this view, inflation, the rapid expansion that followed the Big Bang, never stopped. It continues, endlessly. In regions beyond our own horizon, each new bubble that forms could have its own laws of physics, its own constants, its own story. Some might collapse in an instant, others might grow vast and ancient, filled with galaxies and light like ours. If true, it would mean that reality itself is larger than anything we can imagine. Somewhere out there, beyond reach or reason, other universes might be drifting beside us, silent and unseen. The multiverse is not just a scientific idea, it's a philosophical one, too. It asks us to consider whether infinity has boundaries at all, and whether every possible version of existence is already happening, somewhere in the endless dark, cyclic universes, repeating forever. Now picture another possibility, not infinite expansion, but eternal rhythm. In this vision, the universe is not a one-time event, but a cosmic heartbeat, a cycle of creation, destruction, and rebirth. The Big Bang gives rise to stars and galaxies. Expansion continues until gravity at last pulls everything inward again. The universe collapses into itself, only to burst outward once more. Each cycle might differ slightly from the one before, like ripples changing as they spread across water. Perhaps our current universe is one of countless before it, and countless yet to come. Hindu cosmology, ancient philosophy, and even modern physics have all touched on this idea, that time is not a straight line but a wheel, forever turning. If so, the end is never truly the end. It is simply the pause before another dawn. The thought brings a certain peace. Even when everything fades, the universe might breathe again. Like waves upon an eternal shore, existence continues, rhythmically, endlessly, beautifully. The mystery of why the universe exists. Of all the questions science has asked, none is more haunting than this. Why does anything exist at all? Why not nothing? The laws of physics describe how things work, but not why they came to be. The universe could so easily have remained empty, a silent void without matter, without light, without thought. Yet here we are, made of stardust and questions, staring back at the infinite. Some philosophers argue that existence is inevitable, that nothing is unstable, that even the void can give rise to something through quantum fluctuations. Others see purpose or design, an unseen force guiding creation. And some accept the mystery as it is, that we may never know why the universe began, only that it did. Still, in this mystery lies something deeply human, our wonder, our curiosity, our longing to understand. These are as much a part of the cosmos as the stars themselves. Perhaps the why of existence is answered simply by our desire to ask it. Perhaps asking is enough. The universe and consciousness. If the universe exists and we exist within it, then what does it mean that we can perceive it? Consciousness is the universe becoming aware of itself, as many have poetically said. Within the human mind, built from atoms forged in ancient stars, awareness blooms. Our thoughts, dreams, and memories are made from matter that once drifted in the void. Somehow, through processes still barely understood, this matter began to know. It began to observe, to ask, to reflect. The emergence of consciousness might be one of the rarest miracles of all, or perhaps it's as natural as gravity itself, an inevitable outcome of complexity. Some physicists even suggest that consciousness may not be separate from the universe, but fundamental to it, woven into its fabric. Others imagine countless worlds where life never woke, where the cosmos continued in silence. But here, on this small planet, the universe can look inward, through our eyes and wonder at its own creation. We are the stars, thinking, the cosmos dreaming, the infinite given a voice, finding peace in the vastness of space. It's easy to feel small when we contemplate the cosmos. The distances are immeasurable, the timescales beyond comprehension. Stars live and die without knowing we exist. Galaxies spin in silence, never touching, never slowing. Yet within that immensity lies an unexpected comfort. Our smallness frees us from burden. The universe asks nothing of us except that we exist within it, fleeting but real. Every heartbeat, every breath, is a reminder that we are part of something unimaginably larger, a great and ancient story still unfolding. When we gaze up at the night sky, we're not looking into emptiness, but into our origins, the hydrogen in our blood, the calcium in our bones, the iron in our hearts. All were born in stars long gone. We are, quite literally, the universe made conscious, reflecting on its own beauty. In that realization lies peace, not the peace of answers, but of acceptance, the quiet knowledge that we belong here, not apart from the cosmos, but as its living expression. And in that belonging, perhaps, the sleepless mind can finally rest,